Hello, everybody. Thank you for joining our webinar today. First of all, I would like to introduce myself with our partner Patrick Salam from BluePallet. First of all, I'm Alim Blidishel, the platform engineering lead at Wisecube AI, with more than 15 years of experience, solid background in computer science, and passion for data. I have always found myself in the confluence of challenging engineering and bigger than life data solutions. My strong points, one of my strong points that I have is the expertise in big data, and this enables me to make sense of vast amounts of unstructured and structured data, and also extract the valuable insights to drive strategic decision making. My knowledge spans across various big data technologies, several highly scalable and robust data processing systems to handle petabytes of data, crucial for machine learning and data-driven application. I have experienced a lot of cloud knowledge in the last 15 years, and I work with AWS, Google Cloud, Microsoft Azure, trying to use all the time the best practices in the cloud infrastructure. But also, I tried to align them with the AI-driven strategies to facilitate seamless scalability and also performance. Our impact on Wisecube AI as a platform engineer lead at Wisecube AI, together with my team, I have used my combined expertise in big data and cloud computing to develop and manage AI solutions efficiently. And my leadership has been instrumental in Wisecube's growth, overseeing the successful implementation of complex projects while ensuring they remain scalable, performant, and secure. Now, next, I would like to introduce Patrick from BluePallet, who is the co-founder and chief product officer.
Hi, as Aline mentioned, my name is Patrick Salome. I am the chief product officer at BluePallet. BluePallet is a commerce platform for the chemical industry. We service distributors, manufacturers, and end users of industrial, mainly commodity, but also specialty chemical products. Those products span across pretty much every industry that we know and touch today. We've been working with Wisecube now for the past 2 years and have been extremely grateful for the insight that they've brought to the table, and particularly grateful for Aline's project leadership throughout this process. One of the main reasons we decided to work with Wisecube is their vast knowledge in the chemical and pharmaceutical space. The chemical industry itself has two very fundamental but persistent problems. The first is that analog and static data are extremely relevant in the industry and used to facilitate a lot of the commercial transactions from partner to partner. And that data is often outdated and it is often fragmented. So we've been working with Wisecube now for the past 2 years to solve a lot of that and transition that analog and static data into something that's dynamic and something that we can leverage on our platform, but also share with our stakeholders, our customers, to use in their own business. The other side of this is the tribal knowledge within this industry. There is a lot of tribal knowledge that spans across the commercial utility of these products, and there's different perspectives between distributors and manufacturers and end users on what products can be used for and what they're not used for. And by aggregating this information into a knowledge graph that Wisecube has helped us build, allows us to identify opportunities that weren't previously there, and something that we're extremely excited and proud about. So that's it from my side. Aline, I'll pass it back to you.
Okay, thank you, Pat. So I want to emphasize the importance of the work that we have done for BluePallet, and basically, I would like to start with the problem that we wanted to solve, and basically, we have identified the importance of the chemical data sheets in BluePallet's world, and basically we have tried to come up with a solution that can fix that part. So in the world of chemicals and biomedicine, the safety data sheets, or SDS, are the unsung heroes. So they hold the key to understand the properties, hazards, and safe handling of the chemicals. So parsing these documents will give us like the values that BluePallet is trying somehow to obtain then automatically. So with the knowledge that Wisecube had based on AI-driven platform, we have implementing a parsing mechanism for these SDS documents. So by tapping into the largest biomedical knowledge base, Wisecube can extract, categorize, and present crucial data from SDS in a manner that's both actionable and user-friendly. So if we also think about BluePallet, BluePallet stands as a synonymous for excellence in supply chain solutions that recognize the importance of the SDS in the chemical logistic process. So it's like a filed document that cannot be disposable in their process. Okay. If we want to discuss about the benefits of that, is like for the business, this means that whatever we have done, this will reduce risk, compliance with safety regulations, and also efficient logistics. For the end users and also workers, it translates to enhance and safety, confidence in the products they handle. And for the environment, it ensures that chemicals are transported and used with the utmost care and responsibility. So if we take a look deeper to the problem, like these chemical documents such as SDS, PDS, and TDS are the backbone of safety and product knowledge in the chemical industry. However, parsing these documents is a monumental challenge. They are often dense with technical terminology, vary in format across manufacturers, and contain critical data buried within pages of text. This complexity not only hinders quick access to vital information, but also poses a risk of misinterpretation in some of the cases. In them, we can lead to potential safety hazards and compliance issues. In an industry where the precision is paramount, the difficulty in efficient extracting and understanding this data is a pressing concern that demands innovative solutions. And with that in mind, I will move to the slide in them. We are presenting the challenges that we have in order to parse these chemical data sheets. And this is clear that, of course, in parsing chemical data sheets, we faced many challenges like the one presented in this slide, like multi-phase data structures, labyrinth challenge for conventional data extraction methods, often leading to fragmented or misinterpreted information. Furthermore, as in every project, the challenges are time-consuming. We allocated a lot of time for our engineering team in order to solve the issues exceptionally at the beginning when we started to prepare annotations, but with the experience that we accumulate, we have overcome them in the end. The ones presented here, the ideas that are presented here in the slide, are the most important of the challenges that we have figured out, but not all of them. So there are also others that are not presented here, but were not so important. Okay. If we want to do parsing, we need to think about the efficiency on doing that. So with that in mind, in the world of the chemical safety datasheet, as I mentioned, these files are indispensable. But extracting meaningful data from them is no small feat. First, there's the challenge of their complex layouts and formats, which can vary widely across manufacturers, coupled with the task of handling varied data types from textual descriptions to numerical values. The process becomes even more daunting. Add to this the inconsistent terminology and language used, and you have a recipe for misinterpretation. Moreover, data quality and also completeness issue often arise, making it somehow like imperative to verify and cross-check information. The challenge is further magnified when processing OCR data, especially when dealing with scanned or handwritten documents. So this is a very important task that we have to figure out, like if that the file was scanned or handwritten, how do we parse that part and how OCR can help us in that part. But let's not forget the large volume of documents that these industries have to shift through. But it's not just about extracting data, it's also about contextual understanding, grasping the nuances and implications of the information. Plus, these documents undergo evolution over time with updates and revisions that need tracking, exactly what Pat mentioned in the beginning. The silver lining. So advanced AI-driven tools are now emerging, designed to tackle these challenges head-on. So they promise a future where SDS data is not just accessible, but also accurate, comprehensive, and timely. Okay. Next, I want to discuss about the strategy that we use and how we become using the NLP Lab that is delivered by the Jon Snow Lab team. And in this case, to effectively parse complex chemical datasheets, a comprehensive strategy is essential in a way. And here is somehow like a breakdown of our approach presented here. So before doing any parsing, we need to begin before any parsing begins, raw data must be annotated to train our models effectively. Using a specialized natural language processing, like NLP Lab, we label and categorize data, ensuring our algorithms recognize patterns and structure within the sheets. The next step is to have entity recognition and extraction. That once our models are trained, this is the next step involved. This involves recognizing chemical names, properties, hazards, and other relevant details, ensuring that every piece of vital information is captured. Next, we have the noise handling and data cleansing. This is to assure that we are removing errors or hinder accurate parsing. Our strategy involves sophisticated algorithms that filter out this noise, followed by a data cleansing process to ensure the extract information is both relevant and accurate. Next in the process is the contextual understanding, and with this in mind, this means that the chemical data sheets are not just about raw data; they are about understanding the context in which the data is presented. Our models are designed to grasp the nuances and implications of the information, ensuring that the parsed data is not just accurate but also meaningful. Another important step is that parsing speed and efficiency. So this, in every industry where time is of the essence, parsing speed is crucial. Our strategy was prioritized to make this efficient, to ensure the vast volumes of data sheets can be processed in minimal time without compromising on accuracy. And one of the most important steps is the last step, when we had included the human in the loop, and this is somehow like an extra validation that needs to happen. And with the AI and algorithms that play a significant role in our parsing strategy, the human touch remains invaluable. So after the initial parsing, a human expert reviews and validates the extracted data. This dual-layered approach ensures the highest level of accuracy and reliability. Incorporating these aspects into our data parsing strategy ensures that we not only extract information from chemical datasheets, but also understand, validate, and present it in the most effective and meaningful way. Okay, then to present next the Wisecube as a smart parser. So as you may already identify, Wisecube AI is a powerful AI-driven smart parser expertly designed to decode and interpret safety datasheets and other chemical files like PDS and also TDS. We champion precision and efficiency in transforming complex chemical data into accessible knowledge. Okay. In the next slide, we will see like the heart of the smart parser, and this is basically the Wisecube smart parser architecture. And we see the sophisticated system that was built primarily using Python. As its core, it exposes a Flask API, ensuring a lightweight and efficient interface for users. Delving deeper into its parsing mechanism, we can identify the parser mechanism using TextAct, that it's a service provided by AWS, and it's used for extracting text from various documents formats, ensuring comprehensive data retrieval. Then Tika, as a versatile tool integrated to parse and extract metadata, further enhancing the depth of data extraction. Then the pre-configured and the NER model internally created by our team that somehow like used advanced techniques to identify and categorize specific entities within the text, such as chemical names, properties from different sections inside the SDS documents. Then we have come up also with including the large language models, the LLM, as a robust component that aids in understanding context, ensuring the parsed data is not just accurate but also meaningful. And last integrated algorithm was the confidence computation. So after parsing, the system calculates a confidence score for the extracted data, providing users with an insight into the reliability of the parsed information. In essence, Wisecube Smart Parser is a harmonious blend of cutting-edge tools and techniques, all geared towards delivering precise and reliable parsing of safety datasheets. Okay. The next part, it's the integration that we have done, including AWS Wisecube. So to bolster its integration with also the BluePallet strategy, Wisecube has taken a significant leap forward by developing a GraphQL Java API. This modern query language ensures a more flexible and efficient data exchange, allowing for precise data retrieval custom built to specific needs. By using GraphQL, Wisecube ensures that BluePallet can fetch exactly what it requires, reducing overfetching and streamlining interactions. Furthermore, the inclusion of AWS MQ managed message broker service amplifies the robustness of this integration. So AWS MQ can facilitate also seamless communication between applications, ensuring that data flows smoothly and reliably between Wisecube and BluePallet. In essence, this strategic development not only enhances interoperability, but also paves the way for more cohesive, responsive, and efficient collaboration between the two platforms that we have built. Okay. Then a very important step and aspect in our smart parser is computing the confidence level. The confidence level is a crucial aspect of data parsing, ensuring that the extracted information is not just accurate but also reliable. Here is a breakdown of the strategy that we have included. So the foundation of our confidence computation lies in the data derived from multiple algorithms. So the algorithms that we have used contain the power of the TMA parser that is internally the parser that we have built, then Spacey and also ChatGPT that we have integrated. Each of these algorithms offers unique strengths in parsing and understanding data, providing a diverse set of predictions. Before diving into computation, a general guideline is established. This ensures consistency in how predictions are evaluated and how confidence scores are derived across different datasets and contexts. With the algorithms in place, the next step is to generate predictions. These predictions represent the algorithm's best guesses or interpretations of the data. Each prediction is then translated into a confidence score. This score is then quantifies the reliability of the prediction, with higher scores indicating greater certainty. With multiple algorithms at play, we have multiple confidence scores for each piece of data. These scores are then combined using various methods, like the one presented here, like simple averaging, weight averaging, and staking. So all of them are combined together in order to obtain like the real confidence level that we expose as the final value. Finally, after combining the scores, we arrived at the confidence level estimation. In summary, the confidence level computation strategy is a process that harnesses the strengths of multiple algorithms, combines their insights, and delivers a quantified measures of certainty, ensuring that user can trust the parse data accuracy and reliability. Okay. Here on this slide, we can see the full architecture between Wisecube and BluePallet and how all the pieces are coming together using like AWS. So for the development, it's used for the integration of Wisecube and of BluePallet. We have built on the robust infrastructure of AWS, and we promises scalability, reliability, and efficiency. And we also have come up with a conceptual overview of this architecture and what we are using as data storage. Then what we are using as as data storage, we are using the S3, AWS S3. Then how do we process and parse the data using Python and AWS Lambda functions? Then API integrated with using Beanstalk and API gateway for security and for making sure that it can be monitored using AWS CloudWatch. Then a database like RDS databases for the parsed data, for the metadata that we are storing, and for the AI and machine learning part, we have tried to play around with SageMaker and use that models on that side. Okay. In essence, if we want to conclude on that architecture, Wisecube and BluePallet integration on AWS ensure that this collaboration is not just seamless, but also scalable, secure, and efficient. This architecture is pretty much designed to handle vast volumes of data, complex parsing operations, and ensure a smooth communication between the two platforms. Okay, next step is to see how the SmartParser works, and to present one of the most important strategy that we used and steps into our processing work. So navigating the landscape of data parsing, especially in complex domains like chemical safety data sheets, it requires like cutting edge technologies and human expertise to create something that it's consistent for the vendors. So the journey begins with the data annotation using the well-known Johnson Lab's NLP Lab. Raw data, it's annotated and labeled. This step is somehow like essential. Tika plays a crucial role in the initial stage of parsing. Then AWS extract is like the further enhance the extraction process, especially for documents with complex layouts of those that are scanned. Then it comes the LLMs with their vast knowledge bases, aid in understanding the context of the extracted data. And at least we have the NER models that are the workhorses of entity extraction. They identify and categorize specific entities within the text, such as chemical names, property, or hazards. And when I want to point right now the NLP Lab, that the annotations from Johnson Lab are further utilized to train the specialized NER models. So these models, custom built for the datasheets, ensure a higher degree of accuracy in entity recognition. While AI and algorithms play a significant role in the smart parser operations, the human touch remains invaluable. After the initial parsing, human experts step in to review and validate the extracted data. This dual-layer approach ensures the highest level of accuracy and context awareness. In essence, the Smart Parser is a symphony of advanced technologies and human expertise, all working in tandem to ensure that the data extraction from complex documents is not just accurate, but also insightful and actionable. Okay, here we can see the development for the Smart Parser. How easy it's to deploy and what framework and what tools until the API. So like Python, then Flask, then the tools that we have used and that I already mentioned in the previous slides, and also the API that was built as a endpoint to use the Smart Parser. Okay. This is a slide to emphasize the sample response that it's coming based on from an SDS, from a template, from a sample SDS document that includes like the confidence level. So as we can see here on this slide, it's like the we have like each section. This is only part of it, and I wanted only to emphasize the confidence level for each detected field that comes directly from the Smart Parser automatically. Here we can see that basically through an API-driven approach, the Smart Parser seamlessly integrates with Johnson Labs, leveraging the NLP Lab for automated annotations. And I will present directly after this slide a short demo. This synergy capitalizes on a pre-built train model that was specifically custom built for SDS documents. So if we need something for TDS or PDS, we would need to build custom-made models in order to have that pre-annotation available. Okay. Then why we have picked natural language processing and the NLP Lab? It's because of the rapid development of language-based application, significantly lower costs by streamlining processes, and also it offers like continual updates to stay abreast of evolving linguistic patterns. Our priority was also to think about security and privacy, and this labs ensures that the integrity and confidentiality of the data. They boost a wide range of services, catering to diverse linguistic needs, and their inherent scalability means they can handle anything from small tasks to massive datasets. Furthermore, their design promotes easy integration into existing systems, making them an indispensable tool in today's digital landscape. Okay, and here we can see a short demo based on an HTML page that we created internally for our clients and also for BluePallet to make sure that we can validate internally our Smart Parser API and integration. And we can see here a SDS file was uploaded, and basically it's sent automatically to GSL, and we will see that file that it's already importing automatic. So our application has already connected to the GSL API, and we will see how that file will be automatically annotated, and in the end, we will see exactly that content. As we can see right now, the process has already started to pre-annotate the file using the pre-trained model that it's exposed on GSL for that. So basically, the HTML page that we created, it interacts directly with the GraphQL API that we have built, and somehow ensures a flexible and efficient data exchange, allowing user to fetch exactly what they need. So here we see all the labels that we have and the automatic annotations. And in case the human wants to change something, it's very easy to only create a new a new session and do an update, and then basically all the information is provided and saved further to our smart parser for the NER models, and also can be retrieved through the API as a validation and as a final result on the smart parser. Okay, as we can see, the final status is submitted, and right now the file was moved to review and it was approved. That means that someone has approved that all the values are correct, and we see that the final status is review, and basically here is the content of the file. So it's a merge between GSL and our smart parser, and this is what we have integrated. So alongside the parsed data, users can also see the confidence levels, that it's giving them insights about the reliability and about their data. So in essence, this demo showcased the harmony between cutting-edge technologies and user-centric design. The Wisecube Smart Parser, with its end-to-end integration, promises not just accurate parsing, but also an experience that's smooth, intuitive, and efficient. Okay, thank you. Thank you, and I'm waiting for questions.